Welcome to CIVIL-MECH-MATHS-CONCEPTS. Till now, we have released in hydraulics and fluid mechanics 19 lectures. And this is the 20th lecture. And in the last lecture, we have seen that what is the center of pressure and what is the hydrostatic pressure and what is the hydrostatic force acting on the vertical surfaces submerged, fully submerged and partially submerged. Today we will be taking up calculating the total pressure on a rectangular immersed surface. This particular example is very good example and will be useful in gates, in dams, and in the design of many hydrostatic structures. And it can be asked either in engineering services examination UPSC or GATE examination or SSC JE examination or Public Sector Commission AE examinations. It's a very good example I have taken, and I will be explaining how to calculate the total pressure in some of the examinations here. This question is asked directly or indirectly. Please go through the question papers, and after getting the concept from here, you try to solve. If you have any problems, please give a comment to me. I'll reply to your comment with the correct answer. It is asked in multiple choice question also. It is asked in the descriptive question paper also. May not be the same question, the same values, but with a similar concept it is asked. When you understand this concept, you will be able to answer those questions very easily. Now, we have to calculate the total pressure on rectangular immersed surface. We will try to understand what is that rectangular immersed surface. For example, there is a water surface up to this level. Water surface up to this level. Water surface is there. Then there is as explained in the last, the vertical surface when seen from top view, it is like a line. It is top view. It is like a line. When you see from side, it will be like this. It is, let us say, A is the width. Let us say A meters. And D is the depth of that surface. That depth is coinciding with water surface. The water surface either should be coinciding with the top surface of the rectangular surface or above it. Then only we can call it as immersed, fully immersed. Please remember these words. Regarding these conditions I have explained in the previous lecture. Please view my previous lecture. It is the top view. It is the side view. When top view and side view are like this, the pressure will be acting like this. Water is there. water pressure will be acting this way. Then what will be the pressure diagram? With depth, pressure increases. My previous classes on fluid mechanics. First 3-4 lectures, please view them for properties and regarding pressure. Now, pressure diagram will be like this. Pressure will be acting this way. As it was given in the banner, it is the pressure. Pressure diagram. This is the surface on which pressure is acting. Pressure diagram is like this, and force will be acting because it is fully submerged. And the water surface and top surface of the rectangular cross section are coinciding. Then center of gravity coincides with the center of pressure. Please make a note of it. If water level and top surface coincide, it implies the center of pressure is equal to center of gravity of the cross section. Where is the center of gravity of this section? Center of gravity is at a height of d/2. This is the center of gravity. The total force will be acting at this point, center of gravity. Then pressure at the center of gravity is to be found out. Pressure at center of gravity. This pressure is to be multiplied by the cross-sectional area because pressure, the net pressure acts at center of gravity of the surface. Because the center of pressure and center of gravity are same. Now, what will be the net pressure? Pressure net is equal to this will be the height. This is nothing but water height. This is to be taken from the top surface of the water to the center of gravity. That is d/2. d/2 into rho g h. H is rho g into d/2. Now, the point of action of the net pressure is known, and net pressure is equal to rho g h is equal to rho g into d/2. Now, force, hydrostatic force. Force is equal to pressure into area. What are the units of pressure? Newtons per square meter, that is equal to Pascal. The same is the unit for stress also. Stress, pressure, all these have the same units. Force by area, perpendicular area. Now, pressure into area, perpendicular area, perpendicular to surface. Pressure acts perpendicular to the surface. Then force is equal to pressure is rho g d/2 into what is the area? Area of a rectangular is BD. That implies hydrostatic pressure is equal to hydrostatic force is equal to rho GD by 2 into BD, that is equal to rho G BD square by 2. Please remember this. It acts at, force is acting at, acts at center of gravity of the surface, that is at d by 2 from top of the water surface. This can also be one of the questions when the rectangular cross-sectional vertical plane is put in the water under fully immersed conditions. When the top of the surface of the plane rectangular surface and water is same, then what will be the action of the hydrostatic force? The hydrostatic force acts at center of gravity of the plate. Then rho G BD square by 2 is the hydrostatic force that acts, and this is the total pressure. Therefore, total pressure is equal to rho G BD square by 2. This is the formula. Let us do some small example. This type of examples are given in SSC JE examination. Let us say, if A is equal to 1 meter, width is equal to 1 meter, depth is equal to 3 meters, shape is equal to rectangular shape, fully immersed, top water surface and plane surface, that is object plane surface, coincide with each other. Find the total force acting on the plane surface. It's an objective type question. This type of questions are given in engineering services examination, GATE and also SSC JE. Please understand the concept and do it correctly. What is the total pressure? Total force rather, it is not pressure. We will correct it. Total force is equal to rho G BD square by 2. Rho will take it as 1000, G as 9.81 and width as 1 and depth as 3 square by 2. That is coming to 145 newtons. That is equal to 44.145 kilonewtons. This is the answer. Total force acting on the rectangle. The formula we have derived, and from the formula we have done a small example. Whether example is given or whether you are asked to find out the formula, you please understand this concept thoroughly and do it. And best of luck to everybody. And I will close this session now, and I will take up another problem on hydrostatic pressures. A good problem. It is also a very good problem. and mainly suitable for staff selection, SSC JE, and also PSC, AE, and also GATE and engineering services. Thank you for listening to me. Best of luck to everybody. Please subscribe to my channel. If you feel this lecture has added some value addition to your knowledge, please share, view, and review my other videos also, and subscribe to my channel Civil Mech Maths Concepts. Thank you.